Okay, looks like we are live again. Hello everybody. Welcome back to a new video live stream, and in this episode, in this lecture, I'm going to talk about Edge AI, right? A simple explanation, quick, short, sweet. So let's start with machine learning, right? Basically, in machine learning, you have a model, right? And this model is a representation of something that uh, exists in the world. It could be a function, or it could be just it's typically a function, right? Um, and what happens is you have the model as a block, right? And you place that block so that, if you give it an input, you get an output, right? So for example, a facial recognition model would be like, facial recognition, that's the model. You put an image of a face. Actually, let me just draw a little face here. You put an image of a face, and out comes, let's say, a detection, like, uh, right? So that's a model for you. That's a facial recognition model. Now, in order to run these models, they run on hardware, right? So the model is software, right? The model is software and it runs on hardware, like any software, right? And naturally, the hardware is computer, so which means it needs some computing power, right? So like, let's say, let me use a different color here. Let me use purple. So hardware is equal to compute power is equal to some electricity is equal to some size, right? I mean, if it's a computer, it has certain, processing power. It takes some electricity, it runs on a battery or on the power plug, and it has certain size, like it's a physical thing, right? And the problem is, when you talk about deep learning, machine learning models, like the top of the top end, deep learning models, which actually do this facial recognition and a lot of object detection and a lot of other, image or audio focused technologies, all of these models are actually quite big, right? So let's use red again. So deep learning models are heavy, you could say, right? So they need, you know, need heavy hardware, which means more powerful, more uh, power consuming, and also, sometimes bigger in size, right? Your phone has a weaker processor than your laptop in most cases, right? Unless your laptop is from the 1990s or the early 2000s, your phone probably is weaker because it's smaller, right? Simple as that. So now, how does this translate to what edge AI means, right? Um, So let's see. So edge AI, right? Um, so the models need to be there somewhere. So let's say if you have an application, right? An application. Let's say you want, or let me actually do this. Let's say you want to build a smart doorbell, right? A smart doorbell. Okay, that's the project. And a smart doorbell basically means, in our case, that you have a let me use a different color. Whatever, I'll just use a blue, right? Let's say you have a door, right? And you have a little doorbell here, right? And what it does is every time somebody, you know, this is a human being. Every time somebody speaks to their, clicks a button on the doorbell, hits the doorbell basically, then it, does two things. One, it, takes video or captures video, you'd say. Number one, it captures video. Number two, the doorbell camera also detects familiar people. Okay, so let's say you give it certain, let's say it has the ability to recognize your kids and your dog and your family members, right? So how would this detection stuff happen, right? There are two things. One, so now we get into the edge part, right? Now there are two ways to implement this detection for the doorbells, right? Um, One is that it happens on a cloud. So you connect doorbell to a remote computer, or server. So let's say there's another, there's a computer in the house, or there's a um, it's on the internet, you could say. It's on the internet, so it's either connected to uh, through a wire to some computer on within the house, or you know it's connected to the internet. And so basically it whenever to make the detection, it takes an image, and it sends the image to this to one of these computers, the server, somewhere, and then the actual face detection happens on the computer, right? And then it sends back the data that this is like Jimmy or this is Harry or whatever to the doorbell, and the doorbell then speaks the name or something so that people inside the house can see, oh, okay, it's Harry or Jimmy or whatever. That's one. The other one is that the doorbell itself has this computer, on it, a small computer, and detection happens on the device, on the doorbell computer, right? Now, traditionally, this wasn't really possible because the AI software for the detection was so heavy that you just had to send the image to a backend, to like the backend, which would be this computer or the internet or whatever, and then it would send back the results or the detections, right? Now, in this case, the device, right? This device is the edge, right? This is the edge, and this is the cloud, you could say, or the server, right? So let me actually, so in this case, this is the server. Oops. Yeah, this is the server, and this is the edge of the system. So edge means it's right where the data is collected, right? Or actually, can you see this in black or in yellow? Maybe, let me use it. This is the edge, right? And this is the server. And why is this distinction? The edge means it's out there in the world, right? The device is out there in the world. It's in its operational environment. It's collecting data and it's processing the data right where it is. Does that make sense? And this is very different from the cloud. In this case, in edge computing, the doorbell doesn't have to be connected to a remote server or the internet or whatever, right? So you get rid of a lot of infrastructure uh, to exchange the data back and forth for every single thing, every single second and millisecond. However, this means since if you're not exchanging data and you're processing the data right on the device computer better be powerful, right? The device hardware better be able to handle that kind of computation. And that brings us to this whole notion of edge computing, and it's a whole new space where um, let me delete this. So, oops. And to do something properly on the edge, you need number one, um, you know, if powerful, good, like you need specialized hardware, right? Which means new semiconductor chips, which are smaller and take less power and provide high high performance. Performance basically means they're fast, right? So that's number one. And number two, you need specialized software, right? Software that runs on the edge, on the device itself, and is very, again, you know, efficient and compact software, right? That doesn't take too much memory, doesn't take much memory or RAM, so to speak, right? Because by default, when you say edge, it typically means smaller. Small is beautiful with edge, right? So specialized hardware, specialized software for handling all these computation. That's what you typically mean by edge computing or edge AI, right? Um, and there's a lot of companies now which are thinking about, which are trying to build products and services that enable you to build edge AI applications. Um, so far, like it's basically believed that, you know, with every passing year, more and more devices will be smart, right? So That's the key operative word, smart devices, right? Smart devices is the key name of the game, and everybody wants a piece of the new market, right? The new market of smart devices, or somebody wants to build a platform for smart devices. Somebody wants to build a platform where you build applications for smart devices. Somebody wants to manufacture the devices. Somebody wants to manufacture just the chip that will appear in the devices, right? It's a whole new market, and that's what this lesson was about, right? Edge AI. Now you know what that means. It was a very simple, non-technical, beginner's explanation. And I'm going to link to two podcast episodes with two different companies trying to solve some of the toughest problems in Edge AI, right? And please find those links in the description below. And I will see you in the next lesson.